Anomalocaris. Anomalocaris lived during the Cambrian period, more than 500 million years ago. It was not large by modern predator standards. Most estimates put it around 60 centimeters long. For its own time, that was big. The oceans were still full of soft-bodied animals, small arthropods, worms, and early shell creatures. In that setting, Anomalocaris sat near the top of the food chain. Its body was built for active swimming. It had side flops along the body, large compound eyes, and two curved frontal appendages. Those appendages were used to grab prey and move food toward the mouth. The mouth was circular and made of hard plates. Older depictions often showed it crushing trilobites easily. Newer biomechanical work makes that less likely. Its appendages were probably better for softer prey. That still made it dangerous. It had speed, vision, and reach at a time when many animals had weak defenses. It also shows an early step in predator evolution. Before animals like this, many marine organisms had fewer reasons to grow armor, spines, or better movement. Predators such as Anomalocaris added pressure to the whole ecosystem. Dunkleosteus. Dunkleosteus lived much later, in the late Devonian period. It was a plecoderm, a group of armored fish. Its head and front body were covered in thick, bony plates. The rest of the body is less well known because it preserved poorly. Older size estimates make it look much larger. Newer work, however, usually puts large individuals around 4 meters long. The exact size is still debated. Its main weapon was not normal teeth. It had sharp, bony jaw plates that worked like shears. The jaws could open fast and close with high force. That gave it a strong bite and a suction effect at the same time. Prey could be pulled in and cut apart. Dunkleosteus lived in seas with other armored fish, with sharks and large invertebrates. It was built for close-range attacks. The armor protected the head, the jaws did the killing. It was not a fast open ocean shark, it was more like a heavy armored ambush fish. Its danger actually came from short bursts and mechanical power. Once prey got close to the mouth, there was little room for recovery. Deinosuchus. Deinosuchus lived during the late Cretaceous. It was a giant relative of modern alligators and crocodiles. Some species reached around 9 to 11 meters in length. Its body plan was not strange. It looked broadly like a huge crocodilian with a long body, heavy skull, short legs, and a powerful tail. Its hunting method was probably close to that of large crocodiles today. It waded near water, struck from cover, and used a crushing bite. Its teeth were thick and robust. They were not blade-like cutting tools. They were better for holding, puncturing, and breaking. Fossils show that Deinosuchus lived in environments where dinosaurs, turtles, fish, and other animals came near rivers and coastal wetlands. Bite marks on some dinosaur fossils suggest it sometimes attacked dinosaurs. It didn't need to chase like a theropod. Its strength was position, patience, and bite pressure. In its habitat, getting too close to the water was the main risk. It could also use water as cover. A large body looks slower on hand, but in shallow water the same body can launch with force. That made Deinosuchus a threat to animals that were much taller than it. Spinosaurus. Spinosaurus lived in North Africa during the late Cretaceous, roughly 99 to 94 million years ago. It was one of the longest known predatory dinosaurs. Some estimates place it around 14 meters long. Its body was unusual for a theropod. It had a long, narrow snout, cone-shaped teeth, large forelimbs, and tall neutral spines that formed the sail on its back. Its diet was strongly linked to fish and aquatic prey. The snout and the teeth were not like those of Tyrannosaurus. They were better for grip and slippery prey than for crushing bone. The exact lifestyle is still debated. Some studies support a semi-aquatic animal. Other work argues against deep underwater pursuit hunting. A cautious view is that Spinosaurus spent a lot of time near rivers and wetlands. It probably hunted fish, scavenged when possible, and may have taken land animals when it had the chance. It was dangerous because it filled a different role from most large theropods. It was not just a land predator, it was a shoreline predator with size, claws, and specialized jaws. The sail is still debated too. It may have helped display species recognition or temperature control. For hunting, the more important parts were the skull, the neck, arms, and habitat choice. Tyrannosaurus rex. Tyrannosaurus rex lived at the end of the Cretaceous, around 68 to 66 million years ago. It lived in North America. Adult individuals could reach about 12 meters long and weighed several tons. Its skull was massive. Its teeth were thick, deep-rooted, and shaped for cracking through flesh and bone. T-Rex was not dangerous because of speed alone. Its main advantage was the head. Its bite force was amongst the highest estimated for any land animal. The skull was then reinforced for heavy stress. The teeth could break bone and leave deep damage. Fossil evidence, in fact, also shows heel bite marks on other Tyrannosaurus, which means these animals bit each other and some actually survived. It probably hunted and scavenged. That is normal for large predators. Modern predators do the same. T-Rex had very strong smell, forward-facing eyes, and a body built around the jaws. The small arms were not the main issue, since the animal didn't need long arms when the skull did most of the work. In its ecosystem, it was the dominant large carnivore. It could attack big herbivores, feed on carcasses, and defend kills from other animals. Its danger was not based on one feature. It was a mix of weight, skull strength, bite force, senses, and position in the food web. Few land predators have ever matched that package. Titanoboa. Titanoboa, in fact, lived after the non-avian dinosaurs went extinct. It appeared in the Paleocene, around 60 million years back, in what is now Colombia. It is, in fact, still the largest snake known from the fossil record. Estimates place it around 13 meters long, with a weight of more than a ton. Titanoboa was in fact not venomous as far as the evidence shows. Its danger came from size and constriction. Like modern boas and anacondas, it likely grabbed prey with the mouth, wrapped the body around it, and used pressure to stop blood flow and breathing. In a warm tropical wetland, that method would work very well. The environment also had large fish, turtles, and crocodile-like reptiles. Titanoboa may have eaten a range of aquatic and semi-aquatic animals. Its size, of course, matters because snakes are limited by body temperature and available prey. A snake that large points to a hot, productive ecosystem. It also means the animal did not need speed over long distance. It just needed a good strike range, strong muscles, and the right position. In water or at the edge of water, that was enough. Against many animals, the first grip would decide the result. A body that heavy could hold prey on the water, wrap around it, and keep pressure on until resistance stopped. Livyatan melvillei. Livyatan melvillei lived during the Miocene. It was a predatory whale, related to sperm whales. But it wasn't built like a modern sperm whale in feeding style. Modern sperm whales mostly use suction to hunt squid. Livyatan had huge functional teeth in both the upper and lower jaws. Some teeth in fact reached about 36 centimeters long. These were among the largest biting teeth known from any animal. Its body length is usually estimated around 13 to 17 meters. That puts it in the same general size range as large modern whales, but also with a very different predatory setup. Its skull and teeth suggest it attacked large prey, including other marine mammals. It lived in oceans that also had large sharks, including Megalodon. That does not prove constant fights between them, but it does show that the Miocene seas had multiple giant predators using the same broad food base. Livyatan was dangerous because it combined mammal intelligence, large body size, and large teeth. It was not just a filter feeder or a squid specialist. It was a whale-sized hunter that could bite and tear large prey. Its skull suggests strong jaw muscles and a feeding style based on direct attack. In practical terms, it filled a role closer to a marine macropredator than to most living whales. Megalodon. Megalodon lived from the Miocene into Pliocene, roughly 23 to 3.6 million years ago. It was the largest known shark. Traditional estimates often place the biggest individuals around 15 to 18 meters long. Some newer studies, however, suggested longer and slimmer body shapes, but the exact maximum size is still debated because most fossils have teeth and vertebrae, not full skeletons. Megalodon had large serrated teeth, built for cutting. Its prey included whales, seals, sea cows, sea turtles, fish, and other sharks. Fossil whale bones, in fact, with tooth marks support this feeding behavior. Young megalodons likely used coastal nursery areas. Adults could move through broader marine environments. It was not simply a scaled-up great white shark. Its body shape, behavior, and relatives is still debated. What is clear is its ecological role. It was a giant macropredator that targeted large marine animals. Its bite, size, and tooth design made it one of the most capable of predators in ocean history. With that being said, megalodons actually disappeared around 3.6 million years ago. The likely causes include climate change, shifts in whale populations, habitat change, and of course, competition with other predators. Its extinction shows that size alone was not enough. A predator that large needed a huge and stable food supply, because when the oceans changed, the system stopped working.